Hello everyone, welcome to the beginning of this YouTube channel where I will start off by doing LeetCode solutions to easy problems and maybe in the future do like tutorials for Java or Python. The first problem I'm going to solve on this channel is LeetCode problem number 21, which is to merge two sorted lists. So we're given two heads of two sorted lists, list 1 and list 2, and the goal is to return them in one single sorted list. So in example 1, we're given 1, 2, 4 and 1, 3, 4, and it returns a big list of the numbers together. In example 2, we're given two empty lists and we just return another empty list, and in example 3, we're given an empty list and a non-empty list, and so we return the non-empty list because if one is empty, we can simply return the other one since there's nothing to sort it with, and vice versa, this also applies. So here are the lists from example 1. We have 1, 2, 4 being list 1 and 1, 3, 4 being list 2. So since our linked lists are already sorted, we can simply populate the dummy lists by creating nodes and moving the pointers of L1 and L2. For example, we check, okay, is list 1's value smaller than list 2? In this case, they're the same, so it doesn't really matter which one we put, but we'll just put L2 for now. So we put L2's value here, 1, and then we move L2 to the next node. And then we keep comparing list 1 and list 2, and that is how we're going to construct our list because they're already sorted. So list 1 has a value of 1, list 2 has a value of 3. We compare them. Which one is smaller? Since we want it in non-decreasing order, we know list 1 is obviously less than 3, so we put list 1's value, and every time we put the value, we move the pointer. So again, we make a new node, and then we check. We compare list 1, list 2, list 1 is smaller, so we put a 2, and then we move the pointer. And then we compare 3 and 4, 3, we move the pointer to list 2. Okay, and then we check again. In this case, they're the same, so we'll put list 2's value, and then we've hit a null. But as you can see, our list is not finished because we still had this missing value from L1. Once one of the lists hits null, we can simply append the rest of the other list that is not null to the end of our dummy list. Because since it's null, there's nothing else to compare it to, so we can just append or point our dummy list to the non-null list. Okay, so now that I've drawn a little bit, we can solve example 3, the edge cases, using a simple if condition. So if one of the list is empty, if list 1 is null, we simply return the other list because there's nothing to compare it to. And the same holds true for the other list, as I explained. So if list 1 is empty, we return list 2. If list 2 is empty, return list 1. Then, like I said, we need to make our dummy list. So we'll make a dummy head, which calls the default constructor. It doesn't hold a value, it's just a placeholder. And then we make a pointer so that we don't lose the place of the actual head, so we can traverse the lists. Okay, so we have our dummy head, and while list 1 does not equal null and list 2 does not equal null, we're gonna compare the values. If list 1's value is less than list 2's value, we're gonna set our dummies.next to be list 1's value, a node with list 1's value, and then we move list 1's pointer to be its own next. Otherwise, if list 2's value is greater or they're the same, the if condition won't be executed and we'll just put list 2's value in the dummy list. So we'll put dummy.next equal to new list node list2.val, then we move list2's pointer to be its own next. And finally, we must move dummy to be its own next as well. So then this while loop will be broken once one of the lists becomes null. So like I explained, when one of them becomes null, we simply point dummy's next to be the non-null list. So if list 1 is null, dummy.next is equal to list 2. Otherwise, that means list 2 is null, dummy.next is equal to list 1. And finally, we return dummyHead.next, because if we return just dummyHead, it doesn't have a value. Our first legit node that has a value is going to be the next node of the dummy head. That's why it's called the dummy. It's just a placeholder. And if I run this, hopefully if I didn't make any syntax errors, we should be good to go. Alright, so 100% and 65%. Regarding the time complexities, it depends on the number of nodes in the list, which gives a big order of n notation. Okay, so that was all for my first YouTube video. I hope you all learned something, and please like and subscribe. I look forward to making more educational videos in the future. Hopefully I'll get better at making them as well, commentating. It's kind of weird just speaking into a microphone. But I hope you all enjoyed, and I'll see you in the next video.